Okay, algebra. So we are looking at exponential functions through the lens of the rule of 4, and we've done some problems. We did a problem where we started with the equation. We did a problem where we started with a written description, and we did a problem where we started with a table of values. So what's left? Starting with the graph. So I want to make sure that we're all on the same page, quite literally. So please pause the video and get here where you have all of this folded and written out so you're ready to take notes with me. Okay, if you are back, that means you have everything written out and ready to go. And now I am going to draw a graph. Here's my X, here's my Y coordinate plane. We're going to start with a graph. So I am going to start, let's see here. I have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There we are, 8. Okay, put the arrow a little bit further up. So I am going to tell you I've got 1.01. I've got another point, 1, 2. I've got another point, 2, 4. And the last point, 3, 8. I'll also throw in the -1 value. We also have a point, -1, 1/2. Now we know what that general shape is going to look like, so we're going to shoop. We've got that exponential curve where it sort of looks like a U on one side and just a flat line on the other. Now the question is, can you, given this graph, determine the equation, the table of values, and the written description? Let's see if we can do it. I think we can. I'm going to start with the table because I almost actually have the table already. I just have to put it in table form. So I've got X, I've got Y. And I'm going to show off a little by making my table kind of big. So I've got -1, 0, 1, 2, 3. That's the information that I have. I'm going to even go with 4 so I can tell you what the next value is because I'm that good. All right, so I have -1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8. What is gonna come next? Well, I notice each time I go, what am I multiplying by each time? That's right, 2. I'm multiplying by 2 times 2 times 2 times 2. So if I'm multiplying by 2, that tells me that my next value, 8 times 2, should be 16. Nice. Okay. Next, if I want to talk about this as a written description, when I keep multiplying by 2, what does that tell me? That tells me that my growth factor is 2. B equals 2. Now I need to figure out my initial amount. I need to figure out what A is. All right, now to figure that out, I can look in a couple of places. I can look here where the table, X is 0, or I can look at the graph here where X is 0, where it crosses the Y-axis. So my initial amount is 1. Let me change that, is 1. We could also say A equals 1. Now, if we're following the form, y equals a times b to the x power, we would say y equals 1 times 2 to the x. Now, I would totally accept y equals 2 to the x. That's fine. But if we do that, our initial amount is kind of hidden. So I like this form best. And what do we see? Y equals 1 times 2 to the x. This is kind of like our most iconic, I don't know why, our most iconic, most form of exponential growth, right? We're starting at 1 and we keep doubling. There's sort of something nice about that. Okay, so we have gone if we think back, we've gone from the general look at exponential functions. We started with an equation and determined all the other values, the other expressions of this function. We started with a written description, and we looked at how that informed what our equation table and graph were. Maybe we started with, I don't even remember now what this one was. Here we started with the written description. I think here we started with the table. Okay, table, written description, and then this one we started with the graph. So do we have room for one more example? What could it be? Find out in the next video.